All right, guys, this is for everybody that's been absent or you didn't quite get what you needed in class. This is starting 3.1 Law of Sines. Mr. Coe did this with first and seventh periods. So let's look what you remember about sine. Okay, and first thing that I pointed out to my kids was that hopefully, or what they told me, they remembered SOHCAHTOA. So if you did SOHCAHTOA, that's how you spell it. So what we're going to focus on is that we're going to work with, remember we said we're working with law of sines today. So this one's the one we're going to focus on. So that means sine equals opposite over hypotenuse. Okay, so if we had this triangle right here showing you, we would have sine of, let's start with something like A. Sine of A is equal to, okay, what's opposite? 3 is opposite, this is opposite, and this is hypotenuse, so 3 over 5. And some of the kids took time in class to show me that they got that. And then I said, okay, what about if you look at B? So this is reference angle A. So if I say sine of B is equal to what? Well, it's going to be opposite over hypotenuse. But for B, let's go back and make B green. All right. So B, opposite for B is going to be 4. This is still hypotenuse because hypotenuse doesn't change. So that should be 4 over 5. Now, if you're given that sine of A is 3/5, then we can actually use a calculator to find sine of A. And a lot of the kids didn't remember how to do this. So what you have to do is sine inverse, because you know sine of A, you can't just solve for A by dividing by sine. That's not possible. Sine is something that you're doing. It's a ratio. It's representing a tiny little decimal. And you're thinking, well, you can divide a decimal, but the only reason a decimal is there is because it's sine of something, sine of A. So what you have to do is you have to do sine inverse of both sides. So to solve for it, you would say sine inverse of this, and then sine inverse of this. And that's really tiny. Sorry, I've had to squeeze it in there. All right, so the sine inverse and sine cancel each other out. It's kind of like saying divide and multiply by the same thing. So this leaves you the measure of angle A is equal to, all right, sine inverse of 3/5. All right, so here's what I'm going to do. I'm going to pull up a calculator. I'm going to show you how to do this. You're going to hit, oh, look at all this stuff on there. Cleared out. Second sine, and do you see the sine inverse right there? Of 3/5. Now, you have a choice. You can do 3 divided by 5 because that's what a fraction means, or you could have used the N over D button. So the next one I do, I'll do the N over D button. So on this, I got 36.9. I will give it 1 decimal place. The measure of angle A equals 36.9 degrees. And the angle A, angles should be in degrees for this unit. We will get to radians eventually. And so this is 36.9. Now I'm going to do the one in green. Now there is another way, but we're going to check it that way, all right? I want to do this one, and I know what I have to do is sine inverse of 4/5 to find B, okay? So the measure of angle B is equal to whatever sine inverse of 4/5 are, so, or is, whatever that is. All right, so second sine of 4/5. Now I told you I was going to use the N over D button, so you can do 4 over 5 or 4 divided by 5. It does not matter to me what you do. All right, 53.1, 53.1, 53.1, and then over here, 53.1. Now, you should remember one thing about a triangle, and that is the sum of the angles in I'm doing shorthand here, in a triangle equals 180 degrees. That is extremely important. So what is this angle right here worth at C? Well, there's a box. You better know it's 90, okay? So if I take my calculator and I add up 90 plus 53.1 plus 36.9. Oh my gosh, I got 180. I must have done something right. How about that? All right, so yay. So 36.9 plus 53.1 plus 90 equals 180. We had to be right. So does that mean that once I found the measure of angle A, I could have just added it to 90 and subtracted from 180? Yes, you could have. Okay, end of story. Yes. All right, so solve for C in two ways using the sign ratios. Well, you can stop or pause the video and you can find it, but I'm going to work straight through it on both of these. So first of all, I know I have this and side opposite, and I've got my right angle, so this is the hypotenuse. Now, one thing I am going to call this hypotenuse is usually, like when this is B, the big angle B, this is side B. So if this is C, this is side C. And if this is angle A, this is side A. You'll see us reference that a lot during this unit, but it is okay to call it AB, side AB as well. Okay. So I'm going to show you one, and we'll see if you can do the other one. So I know that sine of B, which is 46.5 degrees, sine of B equals opposite over hypotenuse, 4 over C. Now, I would like you to know, you know what? I'm going to multiply both sides by C. I would like you to be able to solve this without changing it all into decimals. Now you can, and it'll work. But I'm going to multiply both sides by C. And then when I've done that, I've got this. So I'm going to rewrite that. C sine 46.5 equals 4. And then I would divide by what's attached to C, sine 46.5 sine 46.5. This cancels, all right? So C equals 4 over sine 46.5. There are times that I will make this a multiple choice answer. Instead of giving you the actual answer, you actually have to have it in terms of sine, all right? If that's the case, you're done at this point. If the answer is a decimal that you're looking for, then we need to put it in the calculator. You may do it by 4 divided by, or you can hit N over D and put 4 over, wow, that was weird, sine 46.5. Close the parentheses. See how it looks the same? Enter. All right, so 5.5. So this side is equal to 5.5, all right? There is no reason why we couldn't have gone ahead and just straight put in sine of 46.5, enter, and you could have gotten this tiny little decimal and you could have replaced it with 0.7254. 0.7254. The only problem is it starts rounding and these numbers can get a little messed up, just so you know. Now, with that said, what about, can you find the angle? Oh, we're just going to try to find this a different way. And we can do it going from angle A. So using angle A and not B, can you set up another way to solve it? You're welcome to turn it off. I'm going to go ahead and do it. All right, I know that this is 90, and you are welcome to use 90 minus 46.5, or you can add them together and subtract from 180, because if this is 90, 180 is is double that. So that means between this angle and this angle, you've got 90 degrees. That's 90. So I'm going to use my calculator and say 90 minus 46.5, enter. I got 43.5. 43.5, okay? That is a decimal right there. So I do sine 43.5 equals 3.8 over C. And C should come out to be 5.5 once again, all right? To finish this out, I'm going to multiply both sides by C, and that will give me, this cancels, and that will give me C sine 43.5 equals 3.8, almost said 38. And now I'm going to divide by what's attached to C, sine of 43.5. This cancels. C is equal to 3.8 over sine 43.5. And that will be in parentheses, but your calculator asks you for that. All right, so I'm going to do N over D, and I'm going to do 3.8 divided by sine 43.5. Close parentheses. Whoops. I just did divided by instead of doing the underneath. Okay, I just decided to put that over 1. I should get 5.5. I should not have hit divided. I saw this line here and just did divided by. It's the same as setting up the whole fraction. With me putting a divided up here on top, it messed it up. So we still got C equals 5.5. That's exactly what we were supposed to get. Okay, going on. Is this true? Prove why or why not. Well, first of all, they said 6 over 8. One of my students, and you're welcome to pause this and think through it before I give you the answer. One of my students said, well, first of all, the hypotenuse has to be the longest side, so 8 would not be the longest side. So at best, it would be 6 over 9. Okay, so one thing to do would be, well, let's find sine of A. So if we find sine of 40.8, what is that equal to? Well, sine 40.8, enter, 0.6534, 0.6534. Now the question is sine of A equal to 6 over 8? Well, we can turn that into a decimal. 6 divided by 8 is 0.75. Oh, they're not equal. So the answer is no. I had somebody else in another class to say, well, it couldn't have been because we didn't know all of these angles, and not one of them say it's a right angle. So the actual answer is no, and it is because, this is shorthand, because no right angle. And this is my shorthand. This right here is my shorthand for angle. It kind of looks like a smashed L. It's the symbol for angle, so I use it a lot when I'm writing. All right, moving on. So on this one, I gave you a hint, and I made the A, B, and C really big because it was kind of hard to do. So solve for the sine of A. And if you're looking at this going, where are all the numbers? There aren't any. So what I'm going to do is I gave you a hint that we can draw in this altitude, and we can call it h for height. Okay? You could have called it anything you want to call it, anything at all. And these are incorrect, so while we're looking at them, I'll just go ahead and mark them out. So what I want you to do is I want you to find sine of A. So sine of A, without this altitude drawn in, there is no hypotenuse. So what we have to do is insert where there would be a right angle. And in this, for sine of A, you see angle A? It's part of this little triangle right here, okay? It's part of this triangle where there is a hypotenuse because we don't know this length of B if angle B up there is a right angle. If it were a right angle, that would be great, but we don't know that. So what you're going to do is you're going to say it's opposite over hypotenuse. So this is opposite is H over hypotenuse, which is C. Then you're going to solve for H. So you're going to multiply times C. This cancels. So H is equal to C times sine, let's put a dot right there, sine of A. Now I want you to do the same thing for C. Here's angle C. Let's get another color. We'll go to green. So we have another color, and here again, I want to use opposite over hypotenuse. Notice opposite that's dealing with a hypotenuse is H and A. Multiply both sides by A. That cancels. And so H is equal to A sine of C. Now, what we notice here is that I have an H here and I have an H here. They match. So what I have is C sine of A equals A sine of C. Now, to save us some time, I am going to be very creative with what I divide by to clean this up and make it prettier. Notice I have a C over here and an A over here. I'm going to multiply, or divide, excuse me, by A times C, A times C. Now, I want you to look at what happens. This A cancels, this C cancels, and I did have kids ask me, what about this little a and the big A? Don't they cancel? Or this C and that C, don't they cancel? Well, this C on the bottom is a lowercase c. I'm going to give it a little bit of a tail. All right, so this C, and I'll give this one a little bit of a tail. All right, this C that we're talking about, oh, that one shouldn't have a tail. There you go. I messed that one up. Let's take that one off, and I'll put the C back in here. That's a capital C. The one that would have the tail on it is the side C, which would be this one. This is over side C, okay, not the capital C. That would be the ones with a tail. The one that's capital C doesn't need to be taken off. Okay, so these C's cancel, okay, and this is a capital C. That's the angle C. It will not cancel there, all right? So what we have left is sine of A over A equals sine of C over C. Would you look at that? It's a little bit easier to remember. So I'm going to help you out with this next one, and I'm going to redraw triangle ABC because I kind of messed mine up with this right here by giving you a hint. So this is A, B, and C again, and I am trying to find sine of C, sine of B. So these are going to be my two reference angles. So if those are my reference angle, I'm going to insert an altitude right here. And you know what? I'll just put a box on each side. Now, what I want to do is I do want to go ahead and put in that this is the side C and this is side B. I am going to need those. Well, I need to call this middle line something. Let's see. What do we want to call it? ABC. Let's use D. I like D for this height where we drew it in. Okay, that's another altitude going from one angle, making a right angle with the opposite side. That's another altitude. So this works well as D. So now I have B and C and D, and they kind of make sense going together. So sine of B is opposite over hypotenuse. So that's D over C, and I'm going to multiply by C on both sides. The C is going to cancel. So I have that D is equal to C times sine of B. All right, so sine of C, I'm going to go over here. Whoops, go over here to C. Let's go red. This angle at C, I'm going to put 2 marks there. Its opposite over hypotenuse is D, and this is the hypotenuse because it's across from the right angle, okay? So this is D over B, and I'm going to solve for D again. So solving for B, I'm going to multiply by B, the B's cancel, so D is equal to B sine, and I need to try to remember to print, B sine of C. All right, so this is a capital C. All right, this is an angle. So, and whenever you do sine, cosine, or tangent, it's of a degree of an angle, not a side. Be careful. All right, so notice here I have a D equals and a D equals. All right, so I'm going to set my 2 D's equal to each other. Well, I have B sine of C equals C sine of B. Now, think about what I did over here, dividing by something very particular. I'm going to do it again. I'm going to divide by B and C. B and C. The B's cancel here. The C's cancel there. This leaves me sine of C over lowercase c equals sine of B over lowercase b. All right, so do you see how what we ended up with right here and right here, they match each other. So there's something that we're going to rewrite this, and I'm actually going to use the next page. We're going to, now you see them all right here. Okay, this is everything we just figured out. And what I want is I want to be able to combine all of this at once. So I have sine of A all over A, and notice that's an angle A, equals sine of B over B equals sine of C over C. Now, if you ever see this written the other way around, A over sine A equals B over sine B equals C over sine C, it's the same thing. This is totally interchangeable because all the sides are on the top, all the sine of the angles are on the bottom. So just know this is one and the same, okay? And if you have a preference to write it the other way, I would never count that wrong. All right, so law of sines. So here we go. We have, and I know this is a long video, my apologies for it. I get that. All right, so what do you need to be able to use law of sines? Okay, first of all, you are going to have some numbers because I did get some complaints about where's the numbers. All right, you need an angle. So you got to have an angle. And the angle's opposite side, boom, right there. So what we're going to do is we're going to circle these and we're going to use what you're given right away. And then any other angular side. So it can be anything in here that you can be given, and you can solve the whole triangle. Okay, so can we use the law of sines on this one? Well, here's an angle. Do I have its opposite side? No. So this cannot be solved. Done. Okay. Units, just make sure you use units. If you're talking about angles, they give you degrees. If you're talking about sides, they should be lengths. Anytime they're given to you, you should use them. All right, so let's try these. And in fact, I think this is going to be your easiest one. Let's start with example 1. And I'm going to do a loop around that right there. I want you to see we have an angle and its opposite side. So I'm going to start with sine of B, sine of 85 degrees over 16 equals, I need to know the measure of angle A. So angle A is right here and it's opposite of 7. So I'm going to put sine of A over 7. And weird. I don't know what that is, but I don't need to talk to him. Okay, so let me tell you the way I prefer you to do this. I would multiply both sides by 7. And I have sine of A equal to, this is my answer. Technically, it's not simplified, but my answer's staring at me. When this cancels on this side, I know sine of A is equal to 7 times sine of 85 over 16. Then to finish it off, I am going to have to insert right here sine inverse on both sides, sine inverse, and my sine inverse are gone, and so A is equal to. Technically, it's this, all right? So I'm going to show you 2 ways to do this. The first way to do this is I'm going to pull up my calculator, and I'm going to say 7 times sine 85, enter, divided by 16, enter. Okay, so all of this goes down to 0.4358. 0.4358. Just so you know, that's what that becomes. And technically, you can say sine inverse of 0.4358. I'm going to do that. Except I'm going to do second sine inverse. Okay, so I'm ready. I could type in that number 0.4358, but do you see it sitting there on the previous line? So I'm going to do second answer, enter. It pulled that number in there for me, and I didn't have to type it all in. So it's 25.8. There's my answer, and it is in, oh, this is degrees, 25.8 degrees. So I just found the measure of angle A is 25.8 degrees. This is my answer. Now, I told you there was another way to do this, and I said this is sine inverse of all of this, right? So I want you to notice that I can go ahead, very first thing, sine inverse. There's actually fewer steps to this. And then what I'm going to do in the parentheses, there is a fraction involved with this. So I'm going to hit N over D. On the top of that fraction, I have 7 times sine of 85. Sine 85. Close parentheses. On the bottom, I have 16. And then I'm going to arrow over and close my parentheses. Do you see how I made what was in the black and the orange right here? I've got it all there. All I have to do now is hit enter. Oh my gosh, I got the same answer. There it is. That is the inverse sine. So you are welcome to go about this either way. When I do it, I set it up. I'm going to highlight it in blue. I said I was going to highlight it in blue. I set it up just like this, but you're welcome to change it to the decimal just because it makes it prettier like it does down here in pink. You're welcome to change it to the decimal. Either way will get you to the same answer. Okay, let's look at the next one. Okay, so for this one, solve for A. A, if you remember, is the side across from A. It's this side over here. Okay, now that means you need to have two things that match up. Well, here's the only side I have, and this side is only across from this angle. So I need to know this angle. And I had kids tell me today, Miss Butel, you can just take 180 minus those two together, right? Minus 30 plus 89, absolutely. So that's going to give you, what, 20, let's see, 29, 61? Yeah, this is 61 degrees. 61 degrees. So now that I have this side, I am going to start and include this as part of my sign because I have something that matches with its opposite side that I know both things. So sine of 61 over 28 is how I'm going to find A. All right, that's equal to sine of 89 all over A. All right, so at this point, a lot of my kids like to cross multiply. Guys, you can multiply both sides by A, okay? That's fine to do, or you can cross multiply. I have a personal preference of cross multiplying. If you cross multiply, this is what you get. You get A sine of 61 equals 28 times sine of 89. Okay? And to get A by itself, you have to divide by what's attached to A. Well, A is being multiplied by sine of 61 divided by sine of 61. And by the way, these two signs do not cancel. They can't because it's a function. It's something that you're doing to numbers. So you can't cancel. All right, it's not okay. That leaves you A equals 28 times sine of 89 over sine of 61. Okay? With that said, this could be a multiple choice answer, but in this case, it wants to know how many kilometers. So what I'm going to do is make this big N over D, and I'm going to do 28 times sine of 89, close the parentheses, all over sine 61. Sine 61, enter. There we go, 32. So A is equal to 32, and in this case, kilometers. I always look back and make sense out of it. So this is 32 kilometers. This side was 61, and the opposite side was 28. That's 89, which is bigger, so this side's bigger than the original 28. I would say we have really good answers. All right? All right, so let's go on, and my apologies that this is a long video, but I need to do this for the benefit of those who are not going to make it. All right, so find the longest side in triangle PKJ. Now, I'm just going to label PKJ. This triangle does not have to be to scale. One angle could be the wrong size. I'm not worried about that. I just need everything to be labeled so it gives me a representation of what I need to do. K is 72. In fact, that angle's definitely bigger than P, so if you wanted them to be rearranged, you could. PK, so this distance is 6.1 meters. And it said, find the largest side. Well, to find the largest side, we need to know the largest angle. And I don't know all the angles yet, so you're going to have to subtract from 180. So I'm going to grab my calculator and take 180 minus whatever 72 plus 62 is. All right, enter. And that gives me 46. So this angle's 46 degrees right here. All right, so what I do know is that I have a side and an angle that are across from each other. I need that to happen. So I'm going to have sine of 46. Boy, I really needed to know that. Over 6.1 equals the largest side. Okay, 72 is my largest angle. So I need to know side K. All right, so I'm going to go with little k. That's little k over there, not capital K. So I'm going to have sine of 72 over little side k. That is not a capital K. All right, so you can cross multiply and then divide. So cross multiplying. I'm going to cross multiply like this, and that's going to give me K sine of 46 equals 6.1 times sine of 72. Okay, divide by what's attached to K. That's sine of 72. Do to one side as you do to the other. And you can slow this down and pause it whenever you need. So K is equal to, I have no idea what 6.1 times sine of 72. Wait a minute. Somewhere I was supposed to have 46. That should be 46. And this should be 46. So we're going to correct it. I was supposed to divide out and let these two match right here. This should be 46 and 46. So I got looking at the wrong thing. I was like, whoa, 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 that's not right. Okay, so over sine of 46. Okay, all right, so to finish this out and get my answer, this is where it has to go in the calculator. So I'm just going to do n over d, and I'm going to do 6.1 times sine of 72, close parentheses, over sine of 46. All right, enter. 8.06. 8.06. That was to the first place, so let's just make this 8.1. And it is given in miles, meters, my bad, meters. So I got my units included. Okay, so application direction and directions. So a lot of times when you're doing application problems in these, the only way to do it is that it talks about north, south, east, and west. So the only reason we did this is so that it would help some of you on those type problems. All right, the correct way to write it is north 63 east. Okay, well, you're always considered to be right here in the center, okay? North is always up, east is always to the right, west to the left, south down below, okay? Every single time. I know that your GPS system will change it for you, but not on these problems, okay? So this means 60 degrees east of north. So if I'm going north, I'm headed north, okay? Headed up this way, all right? I want to go 63 degrees from here. That should be 63 degrees. It looks more like 45. I wish I'd drawn that down a little bit more, but that's okay. You get the idea. So the 63 is up here, not down below. North, 37 degrees west. So I go north. That's one side, and the other side is 37 degrees west. So this is 37 degrees. On this one, it says south, 22 degrees east. So head south and then go over here on the side that's going toward the east. You come out, and this angle right there is 22 degrees. okay? It's this angle right here. South 15 degrees west, so if you're headed south and you go 15 degrees west, this is one tiny little angle right here. That is 15 degrees. It's this little angle that's right here that I'm looking at, okay? There's your 15. Just so you know, that's how it works. With that said, let's look at this. Two fire stations are 15 miles apart. One's directly east of the other. This is supposed to be a horizontal line. It's 15 miles apart. With station A directly east of B. So that means B goes here, A is over here. Both stations spot a fire. Oh no, there's a fire. Here, there's a fire. Boy, that's really a sad fire. It looks like a hand. We'll put F here for fire. All right. The angle direction from fire station B is north 52 degrees east. So this is north. Wow, that's supposed to be a right angle. 52 degrees east. Don't think I'm 52 degrees east, so let's go back. Erase this. I want it to be somewhat believable. 52 degrees is going to be more than halfway. I'm trying really hard to make it hit that fire, and that fire is just going to have to move. That fire is going to be right there. There's 52 degrees, all right? And I'm going to get rid of my fire over here. All right, so the next thing it says is that the angle direction from the fire from station A is north 36 degrees west. So it's something along this lines where this is 36 degrees west. Now, both of these make right angles. And what we don't have is this lovely little part right here. So I'm going to do 90 minus 52 is 38. So this one is 38 degrees. And then 90 minus 36, 60, 54 degrees. So this one's 54 degrees. This is a hard problem. Thank you, Mr. Coe, for this hard problem. All right, how far is the station from A? So what we want to know is actually little b right here, because it wants to know how far the fire is from station A. And this is a representation. It doesn't have to be exact, all right? But what I do know to set up this equation, I know this angle right here, and I know, oh, I lied. I don't know this. I do know this angle. I don't know this side, but that's what I need to know. So I need that. The other thing that I need is I know this side. Right. Well, let me get one that I don't have, green. I know this side. So I've got to go to the side opposite. I need this angle, okay? Well, if I know this is 38 and that's 54, then angle F, the measure of angle F, I should say, is equal to 180 minus, we got to add this together, 38 and 54. So let's find angle F. 180 minus the combination of 38 plus 54, enter. That gives me 88 degrees. Almost a right angle. That really does look like a right angle right there. So I'm going to put it in black so maybe it'll show up. 88 degrees for angle F. Okay, so I'm going to use the angle F. I've got that. So I have sine of 88 over 15 equals, I said B was the other one I need. So sine of 38 over B, because B is what they're wanting to know. So if I cross multiply here, I will get B sine 88 equals 15 sine, and that is times of 38. Then I'm going to divide by what's attached to B. Well, sine 88 is attached to B. So do unto one side as I do to the other. Then B is equal to 15 times sine of 38 over sine of 88. So grab the handy dandy calculator and get your answer. I will check back with you and see how you're doing.